say a couple of words about what I'm going to tell you today. So basically, I will tell you my story about me creating a file-based router in a single weekend just for fun. But before we dive in, let me say a couple of words about myself. So it won't surprise you that I'm a senior software engineer at Callstack. No surprises there. What may surprise you is that I'm a part of Microsoft MVP program in category of web development, which is pretty strange, taking the fact into consideration that today I'm going to speak about React Native, but, well, I'm a web developer by heart, but I also like working with React Native. So, for example, creating the same application for multiple platforms, including web platform. Moreover, I'm occasional open source contributor. For example, did anyone have this issue with React DevTools that when you run the profiler once, you stop it and you try to run it again, the DevTools would freeze in that case? Anyone experienced that before? Okay, so I fixed that. Like 2 months ago, I fixed that, so thank you. So that's why I call myself occasional open source contributor, because I do not do that often, but when I do, well, I do nice things. And above all, I'm a curious person. I love to peek behind the curtain to see the gears moving, to see how everything works under the hood. Why? Because often I have to work with some performance-related stuff, with performance bugs, with auditing of the applications in terms of performance. So in such cases, that knowledge about how everything works in practice is really, really useful. And that's it. Without further ado, let me dive into the topic. So you can ask me, Szymon, why on earth did you decide to work on a file-based router in your free time on a weekend when you had so many, well, more interesting things to do, like playing computer games or playing, I know, on PlayStation or going out for a walk? Well, there are a couple of reasons for that. First of all, like I said, I'm a curious person, so I just wanted to see how hard it is to create something like this. Because such pattern, file-based routing, is super common on web, and I'm a web developer by heart. And React Native is falling behind. We have, I think, only one implementation of file-based routing right now. Plus, like I said, I like to have this peek behind the curtain to see how the things are working in reality. Plus, I like to challenge myself from time to time to kind of stay sharp and still be a good developer despite, taking more management tasks on myself. So, current state of things. If you create any React Native application right now, you will use React navigation. That's kind of common strategy. And the thing is that if you look at this code, you will clearly see the hierarchy created by nesting navigators inside screens. And obviously, this can go to many, many levels. You can have, usually you have a stack navigator, then you have some other navigator, you can have another navigator inside. So our task today is to convert this component hierarchy into hierarchy of directories and files. And obviously, we will need something like URL navigation. So when you browse the web with your browser, you use URLs to navigate around. And usually, with file-based routing, you need the same thing on in React Native. And obviously, it's straightforward for static routes. So when those routes don't accept any parameters, like /user/me, for example. So this is simple. We just can name our directories or files with segments coming from the URL. The thing gets a little bit complex when we introduce dynamic screens, which can accept multiple parameters. And those parameters need to be somehow reflected in the file system, in the names of our directories and files, so the application will be able to pick it up. How can we do that? And, usually we use we name our directories and files using a special syntax. So this is coming from Next.js, and you probably use Next.js at least once in your professional career or as a hobby. And in Next.js, if you want to have, for example, a screen accepting some parameter like ID, what we do is we use a special syntax, square bracket, ID, square bracket, where ID is the name of the parameter, and that's pretty much it. Next.js automatically extracts this ID parameter from the URL and pass it to our component. And we want to achieve the same thing. What's also neat about that is if we have multiple parameters in a single URL, for example, slash users, slash ID, slash posts, slash post ID. So the neat thing is that the final screen, the final page, will inherit all the parameters from the URL. So you will have access both to user ID or ID, and then you will have access to post ID, which is neat, which is useful. And moreover, with file-based routing, we can also implement things like some neat abstractions over loading states, over error catching patterns. But we will focus on this just, well, later. Now the fun stuff. So how can we implement that? So the first question is how to dynamically import modules. And the problem is that with the default setup of Metro, our bundler, it's not really that easy. You see, Metro doesn't support dynamic require calls by default. You can only require things or import things with literal parameters. So you can import your pages, that's okay, but you cannot import something during runtime. Like you decide that if user writes 1, you will import some file located in the directory named 1. This is usually not possible because of two main problems with Metro itself and how we build our applications. So first of all, we don't want to include every file in our project, in our application from our project. Why? Because with every file, we need to ship some additional data to the end user. Our app will wait more. Generally, that's not a good thing to do. So Metro wants to include only the necessary data and only the necessary code. Second issue is that Metro does some performance optimization under the hood. And of course, we import things by like common names, let's say human readable names. If we want to import React, we import React. But under the hood, Metro exchanges this human readable ID for a numeric ID with a number. Why? Because it's more performant to compare numbers or to look for a particular module by number. So that's why such transformation takes place. The problem is for us that even if we kind of assume that the module ID will be always, 6 or 7, 8, whatever, the default implementation of module ID generator in Metro isn't really deterministic. It can be so that you build your application once and some module will be addressed by ID number 1, but another time the same module may be addressed as module number 2, for example. So the question is what we can do about it, what we can do to mitigate this issue and to import our modules dynamically, but at the same time be compliant with Metro requirements. So my first idea was to basically write a custom script running alongside with Metro, scanning the directory with all my screens defined inside of it, and then basically generating a virtual module, a manifest with all necessary required calls. So if we create a file like this, you see that all imports use literal values. So those are no longer considered dynamic, so Metro will include all of those screens in final application. So to sum up, every time Metro starts up, I scan the selected directory. In my case, it was app directory, just the same like in Next.js. Well, and I generate the manifest from what I find inside. Pretty simple, but many of you may now think about file changes. because we tend to rename things. We tend to create new routes. We tend to delete some existing routes. So what about that? We need to kind of regenerate the virtual module, the manifest file, every time we do some change. And that's a good question. And that was the first time I kind of scratched my head and wondered if I'm going the right way. But okay, we will manage. You may heard the name Watchman, which is basically a tool to listen for file-based events in your file system. So I used Watchman to observe my app directory and basically rerun the same script every time Watchman detected some change. And it worked, like more or less worked. There were some issues with it, and at this point I kind of stepped back and started thinking that maybe I'm doing something wrong. Maybe there is some built-in API in Metro that allows me to import dynamically, import modules dynamically without all those shenanigans, without creating custom scripts, running Watchman, creating manifests. Maybe there is something like simple to be used. So I started digging into Metro itself just to see what's inside. Because, well, there are file-based routers around, and they seem to not use such hacks. And I found out that, well, Metro is more powerful than I initially thought. There's an unstable method called require.context, which essentially replaces my whole implementation, my whole custom implementation with Watchman with a single call. And it makes possible to scan your directories, whatever directory you like, and basically have all those modules inserted into your final bundle, and you can obviously import those modules at runtime. All right, so to use this require context, you first need to enable it. It's unstable, it's marked as unstable right now. So you need to put unstable all require context in your Metro config. And after that, you are free to call it whenever you like with whatever arguments you like, as long as those are literals, as long as those are static. They cannot be dynamic, which is at this point obvious. So the parameters go like this. First, the directory you want to ingest. Name is self-explanatory. Second, a boolean indicating whether to include subdirectories. Again, it's super self-explanatory. Third, a regex to filter out unwanted files, if you have any unwanted files in this directory. And finally, a mode which we are not going to go into today. Sorry, folks, I have only 20 minutes and I'm getting out of time, so mode is out of the discussion for now. You are free to dig inside of it yourself. All right, so at this point, we have a list of paths to potential screens. So we have import them. But now we need to consume this list, somehow represent this list of paths, screens in our memory, recreate the screen hierarchy, the screen component hierarchy of React navigation. And at the end, we need to implement something to parse our URLs. So we will be able to replace this URL with a series of calls to React Navigation API to navigate to a certain screen with certain parameters. So in my case, I decided to go with simple tree data structure. So each screen, in my case, is represented by a simple root node instance, which is a simple JavaScript object with 4 properties. Name, which is basically the segment. So if you have URL, user/ID, and we are at the ID level, segment will be this ID. Path will be the absolute path, starting from the root. Screen will be basically the screen component exported as a default from my screen file. And children will contain other instances of root node. Basically, if you have, like I said again, /users/, so everything after the slash will be considered children of users. So then I can traverse the tree and basically match correct roots. So now I have this tree represented by instances of root nodes. And to render all the screens needed by React Navigation, I simply traverse the tree with breadth first search or deep first search. It's not really that important at this point. Maybe it's not the most important, most performant approach, but still it was good enough for this experiment. Well, it was a single weekend, so well, I had to make some choices and some cuts. Nevertheless, now we need to match the correct route according to the URL passed by an user. So we start with URL split by slashes. And then we start our iteration from the root. So we started from the slash node. We check children, if the current segment is equal to one of the children's. If so, we move to this node and continue as long as there are segments left in the URL. Obviously, we need to pay attention to some details, like if we have, for example, this block sample on the bottom of the screen, you will see that one of the roots is static, block slash latest, and block slash slug. So obviously, the slug one will be matched to everything because, well, it's a dynamic parameter. So obviously, we need to sort things first. So static roots will be first to be checked. Yeah, and this algorithm continues as correct root is found, or we have no correct root. So at this point, the only thing we can do is to create an error. And at this point, we have a foundation for a simple file-based router. Well, we can navigate, we can define screens, we can have dynamic routes, dynamic parameters. So let's say it's a basic file-based router. And well, let's add something new. Let's add something, some extra features. And unfortunately, I'm not exactly overflowing with original ideas, so I'm going to kind of go along and again ask you who here has had the opportunity to work with Next.js. So many of you, me too. So you probably will know about this. In AppRouter, you can create special files called loading.js, ts, tsx, jsx, whatever. And this loading file will be used as a fallback for your suspense boundary. So if your component triggers suspense for some reason, if your screen triggers suspense, this component will be used as a fallback, which is pretty neat and pretty useful. The same goes with error files. So you can have error.js, ts, tsx, whatever, and your page, your screen will be wrapped with error boundary, and this component will be used as a fallback. Again, pretty neat stuff, pretty useful stuff. So what do we need to implement in our basic implementation of file-based routing to handle those special files? And it turns out we have to change only two things. So the first thing is that we need to store those two additional components in our root nodes. Because, well, we only need those to say if the page is supposed to be wrapped in suspense or error boundary or both. And during the phase when we basically go through the tree and for each node we render screen component from React Navigation, we basically ignore those files initially. But when it comes to the screen component, we check if in the same directory there is a loading file or error file. And at this point, we can add those to the root node. And well, the last part is basically to wrap our screen component with something like this, with custom root component, which will accept our root node, and check whether there is when there is a loading component defined or error component defined. If one of those is defined, suspense will be rendered, or the error boundary, or both. So we have it. It's done. All necessary changes. Two files, super simple. It sounds like a super complex stuff. Like when you see file-based routing, if you think about how it's implemented, it kind of sounds like a work for, I don't know, months of work, like super complex, super low-level stuff. And now, during those 20 minutes, I walk you through basic implementation, which would probably work in your production applications. But let's not stop there. Let's add something else, like final touch to our primitive implementation. So we don't have access to React navigation screens at this point because we are not rendering them. The app itself is rendering them. So we don't have access to screen options. We cannot hide the header. We cannot set the title of a screen. We cannot do many funny things because of that. So again, the only thing we need to do to support screen options is to kind of say to our users that, okay, if you export from your screen file with your screen component, if you export something called screen options, I will trust you. This is an object with basically screen options. And with that assumption in place, during this root node creation, when we get the screen component from the file, you can look for screen options. Oh, you exported screen options. Okay, I will use it. I will put it in our root node again. And then during the phase when we render all React navigation screens, we will basically use this screen options object and we will pass it to React navigation. Again, super simple. It sounds like a super complex thing to be implemented. In reality, it's super simple. And now time for the most exciting part. And I guess it will break, but we will see. Okay, it runs. So, and it runs not rather smoothly, but nevertheless. If I navigate, you see that my page has access to pretty much every parameter defined. If I click on throw error, I will basically trigger my component to throw error during the rendering phase. And you see that some custom component is shown. It is defined in error.js. So again, it's working correctly. When I click on, what was the name of it? Something with loading, it triggers suspense boundary. Basically, it's throwing a promise to trigger the suspense boundary. And you'll see loading screen. Again, this is defined in loading file as a loading component. And it works. Hooray, 1 weekend of work. Pretty cool, huh? Thank you. Now, obvious disclaimer, this is not a production-grade library at all. There are so many things that can break. The performance may be really awful in some places, but the biggest issue with it right now is it doesn't support nested navigators at all. So if you have your start navigator, you're fine. If you want to use tabs, well, we have a problem. The handling of dynamic parameters is also fairly basic. We don't support any like fallbacks. We don't have any like not found page when for some reason application decides to navigate to something not existing. And like I said, performance could be definitely improved. I'm not sure if the tree structure is the best option we have. Probably not, so that's another place to do some changes. And now the last question to you, or for you. Should I continue developing this library? Come on. Because I don't know, to be honest. I need some, some reason to spend some more time on it. Well, so I guess I have no other choice. So we will see how it goes. You can obviously follow my social accounts, which were visible in the beginning. And at this point, the only thing I have left is thank you.
Thank
Do you have
you.
any questions?